All right, so I hope you remember the most important example from chapter 5. Here we have another problem. It's going to be an application of the same idea. I have a particle that's moving along the x-axis, and I have an expression for velocity, v of t. I have a graph of v of t, and I've been asked to call the position of the particle x of t. And I know that when time is 0, the particle is already at position x equals 5. Can I find the position of the particle at time t equals 3? The answer, my friends, is yes. Here's my suggestion. I can write an expression for the position function using this important idea that we've been talking about. And here's the function x of t. What do I know about x of t? Well, I know it's a position function, so its derivative must be velocity. So I need a function whose derivative is sine of t squared. And I need a function whose output, when the input is 0, is 5. So here I go. This is my initial value, 5, plus the integral from that input first time is 0 to t of, I need this to say sine of t squared, except I can't use t. I can't use x because I'm using that as the name of the position function. I can't use t because it's the upper limit of my integral. I can pick any other letter I want. I'm going to use p. School spirit. Sine p squared. Do not forget your dp. I'm going to make sure that that p squared goes in parentheses, although I don't know that it technically mattered there. Now I have an expression for x of t. I'm supposed to use this, I'm supposed to find the position of the particle at time t equals 3. Well, that's just another way of saying x of 3. So I need x of 3. That's going to be 5 plus the integral from 0 to, look, x was a function of t, which means that everywhere I saw a t, that's what I should replace with 3. You might be wondering, why don't I replace this p with 3? Because aren't I plugging in 3? Well, I'm replacing the t. X is a function of t, and now I want x of 3. That means to replace the t's with 3's, not the p's. I just noticed that's an extra reason not to accidentally use that same variable, because I want to remember that the whole idea of this function is I can change how long I wait to, I'm taking the area under the velocity curve, and what's changing is how long I wait before I stop collecting area. That's what this is a function of. How long do I let the particle move before I freeze the picture and take the area under that part of the curve? So again, this is a problem where you would type this is a calculator okay problem. I'm sure you would get at least 1 point for writing this expression. And probably get another point for actually plugging that into your calculator correctly, typing it in correctly, and getting the result, which I'll compute for you right now. All right, so that's the expression I typed in my calculator, 5 plus the integral from 0 to 3 of sine of x squared dx. Remember, your calculator is not going to be able to accommodate any other fancy variables, at least not by any means I know. It's going to be stuck using x. Don't let it confuse you that you decided that x is going to stand for the position. You're using x as the variable here to find the area under this curve. And your final answer, that at time 3, the particle is at position 5.77356. Make sure you record that answer to at least 3 decimal places.